Okay, so find the Maclaurin polynomials, p sub 0, p sub 2, p sub 4, notice we're skipping some here, and p sub 6 for f of x is cosine x, and we're going to use p sub 6 to approximate the cosine of 0.1. First of all, a couple things to keep in mind. This is a Maclaurin polynomial, so automatically we know that our polynomial is going to be centered or expanded about c or x equals 0. Okay, so that's a really, really important thing to keep in mind. So I always like to write down my little polynomial. Helps me memorize p sub n of x is equal to f evaluated at c plus f prime, the first derivative, evaluated at c, technically divided by 1 factorial, but we know 1 factorial is 1, x minus c to the first power, plus f double prime of c over 2 factorial times x minus c raised to the second power plus dot 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 plus the nth derivative of c over n factorial times x minus c raised to the n power. Okay, so I need to figure out who is f of x. We know that that is cosine of x. That's who we're approximating in this case. I need the first derivative evaluated at x. That is going to be negative the sine of x. I need the second derivative evaluated at x. That is going to be negative the cosine of x. Third derivative of x is, this one is going to be sine of x. The fourth derivative of x is going to be the cosine of x. The fifth derivative of x is going to be negative sine of x. And then the sixth derivative of x is going to be negative cosine of x. Now remember that because this is Maclaurin, we know c is equal to 0. We're centered about 0. So now I'm going to evaluate all of these derivatives, including the original function cosine of x, at c equals 0. And so f of 0, that is equal to the cosine of 0, which we know to be 1. F prime of 0 is equal to negative the sine of 0, which we know is 0. The second derivative evaluated at 0 is negative cosine of 0, which we know is going to be negative 1. The third derivative of 0 is the sine of 0, which we know is 0. The fourth derivative of x, of 0, is going to be the cosine of 0, which is 1. The fifth derivative evaluated at 0 is negative the sine of 0, which is 0. And finally, last but not least, the sixth derivative evaluated at 0 is going to be negative the cosine of 0, which we know is negative 1. Now I'm going to make this just a little bit smaller here so I have plenty of room to work. Need to lock this right here. Okay. Make that. Oops, that's okay. Let me just make everything a little bit smaller now. And move this over here. Okay. So we need to find, the first thing is p sub 0. I'm going to start writing up here p sub 0, okay, is just f evaluated at 0. It's the constant. And so p sub 0 is 1. Now we want to go straight to p sub 2. P sub 2 of x is going to be f of 0 plus f prime of 0 times x minus 0 to the first power plus f double prime of 0 times x minus 0 to the second power, and this is going to be over 2 factorial. And I know to stop there because it's the second degree polynomial, Maclaurin polynomial that we're finding, and that's going to give me an x squared. And so p sub 2 of x is going to be f sub 0 is 1. Now, the first derivative evaluated at 0 is 0, and I could fill in plus 0 times x minus 0, but I know that's just going to be 0. Cross that out. And then the second derivative is going to be negative 1. So we'll have minus 1 over 2 factorial is 2 times x minus 0 raised to the second power. So I don't need really the parentheses there. 1 minus 1/2 x squared. Come over here for p sub 4 of x is equal to, I'm going to write it all out, f sub 0 plus f prime of 0 times x minus 0 plus f double prime of 0 over 2 factorial times x minus 0 squared plus the third derivative of 0 over 3 factorial times x minus 0 to the third power, and then plus, one more, the fourth derivative of 0, come on, pen, there we go, okay, over 4 factorial times x minus 0 raised to the fourth. And so p sub 4 of x is going to be f sub 0 was 1. Remember, this goes away because f prime of 0 is 0. F double prime of 0 was minus 1 over 2 x squared. F triple prime of 0 is 0, so I know that's going to go away. The fourth derivative evaluated at 0 is positive 1, so this would be plus 1 over 4 factorial is 1 times 2 times 3, which is 6, times 4, which is 24, times x raised to the fourth power. And there we go. Now, I'm pretty sure just from this, the pattern we're developing here, we could probably figure out who p sub 6 is, the 6th degree Maclaurin polynomial. That would be 1 minus 1/2 x squared plus 1/24 x to the fourth power. It's an alternating series here, so the sixth power is going to be negative. It's going to be a 1 over, since it's 6 factorial, that's 1 times 2 times 3 times 4 times 5 times 6. 2, 3, 4, 5, and 6. That's 720. And then it's going to be x to the 6th power. Okay? And so that's the 6th degree Maclaurin series polynomial for cosine of x. All right, find the third degree Taylor for f of x equals sine of x expanded about x equals pi over 6. So we need third degree Taylor, and it's about pi over 6. So p sub 3 of x is going to equal f. We are centered at pi over 6, so that would be f of pi over 6 plus f prime of pi over 6 times x minus pi over 6 plus f double prime pi over 6 all over 2 factorial times x minus pi over 6. I just remembered that we forgot to evaluate at 0.01. We can do that. I apologize. We'll do that in a minute here. Plus f triple prime of pi over 6 over 3 factorial times x minus pi over 6 raised to the third. And I know to stop there because that's the third degree. What I was talking about earlier, we forgot to use p sub 6 to approximate cosine of 0.1. And so that would be plugging in 0.1 to all of our x's here. You can do that, and we'll talk about that in class tomorrow. In any case, I need to start finding my derivatives. So f of x is sine of x. f prime of x is going to be cosine of x. F double prime of x is negative sine of x. F triple prime of x is going to be negative cosine of x. And I don't need to go any further. So now I need to evaluate each of these at pi over 6, where we're centered, equals sine of pi over 6. The sine of pi over 6 is 1/2. Now we need to do f prime of pi over 6, which is the cosine of pi over 6, which is square root of 3 over 2. Now we need f double prime pi over 6, which is negative sine pi over 6, which is negative 1/2. And then finally the third derivative evaluated at pi over 6, which is negative cosine of pi over 6, which will be negative square root of 3 over 2. And so the third degree Taylor polynomial of x will be f of pi over 6, 1/2, plus f prime of pi over 6, root 3 over 2 times x minus pi over 6, plus f double prime of pi over 6, so that's going to be minus 1/2 over 2 factorial times x minus pi over 6. This should be squared right here. It wasn't. This is squared. And then plus, it's going to be another minus, plus f triple prime, so that's going to be minus square root of 3 over 2 over 3 factorial times x minus pi over 6 raised to the third power. And now we just got to clean it up. Base of 3 of x, third degree Taylor polynomial is 1/2 plus, nothing really to do here, root 3 over 2 times x minus pi over 6. This is really 2, so that's going to be minus 1/4. X minus pi over 6 raised to the second power. And then minus, this is 6 right here, so that's going to be root 3 over 12 x minus pi over 6 raised to the third power. Okay, for using a fourth Maclaurin polynomial to approximate the value of natural log of 1.1. Now remember, Maclaurin, first clue right there, we're going to be centered at 0. But there's an issue here, okay? 1.1 is really far away from 0. And remember what we were saying earlier in our notes, it's that as you get further away from where you're centered, you get more and more error. So this is not, if we use the Maclaurin polynomial for natural log of x, that's centered at x equals 0. This is not going to be a good approximation. So what we're going to do is we're actually going to be looking at f of x equals the natural log of x plus 1, okay, and then we're going to substitute 0.1 for x, and that's going to be much, much closer for us. Let's see here. So remember, we're using a fourth degree. Piece of 4 of x is going to be f. We're going to be centered at 0 plus f prime of 0 times x minus 0 plus f double prime 0 over 2 factorial times x minus 0 squared. I'm starting to run out of room here. F triple prime of 0 over 3 factorial times x minus 0 cubed. And then finally the fourth derivative evaluated at 0. Let me roll that up. Times x minus 0 to the fourth over 4 factorial. Okay, we need f of x, we know is the natural log of x plus 1. The derivative of that is going to be 1 over x plus 1. The derivative of that is going to be, this is really x plus 1 to the negative first power, so it's going to be negative 1 over x plus 1 squared. The third derivative, evaluated at x, this is really negative x plus 1 squared, so it'll be negative 2 over, positive 2 over x plus 1 raised to the third power, because this is negative 1 to the x times x plus 1 to the negative second power. Bring out the negative 2, it makes it positive, subtract 1. And then the fourth derivative is going to be negative 6 over x plus 1 raised to the fourth power. Now we need to evaluate these at where we're centered. It's a Maclaurin polynomial, so I need to evaluate each of these at 0. F of 0 is the natural log of 0 plus 1. Natural log of 1 is 0. The derivative evaluated at 0 is going to be 1 over 1. The second derivative evaluated at 0 is going to be negative 1 over 1. The third derivative evaluated at 0 is going to be 2. And the fourth derivative evaluated at 0 will be negative 6. I want to go get a different color. So, see if I can fit it in here. Hopefully I can. P sub 4 of x, the Maclaurin polynomial. It's going to be f of 0 is 0 plus f prime of 0 is 1 times x minus 0 is x plus the second derivative is negative 1 over 2 factorial times x minus 0 squared. The third derivative is plus 2 over 3 factorial is 6 times x minus 0 raised to the third power. And finally, minus the fourth derivative evaluated at 0 over 4 factorial times x minus 0 raised to the fourth power. So now I'm going to clean this up. P sub 4 of x is 0. We're not going to write plus x minus 1/2 x squared plus 1/3 x to the third, and then minus 1/4 x to the fourth. I'm pretty sure you could probably keep all of this on going if you wanted an even better approximation, but it said to use the fourth degree, and we want to evaluate the natural log of 1.1. Well, remember, this was for a natural log of x plus 1, so we're going to be substituting 0.1 in for x. 0.1 minus 1/2 times 0.1 squared plus 1/3 times 0.1 cubed and minus 1/4 times 0.1 raised to the fourth power. And so you can type that into your calculator and you'll get some number, and you can tell me what it is tomorrow in class. Okay, just 2 important points. The approximation, again, is usually better at x values close to C, close to where you're centered, close to C, than at x values, further away from C, far from C. Okay, that was the point of the last example there. And again, what I was kind of saying, the higher the degree of your polynomial, the better the approximation. Think back to the sine example that I gave you, and how the more terms we added, the closer and closer and closer that the graph mimics sine. And so that's going to be it for today. We're going to go over the error stuff tomorrow in class. If you didn't understand where, again, in the PowerPoint presentation, where like the a sub 1, a sub 2, a sub 3, where those coefficients came from, don't worry. It's not, I just wanted to show it to you. It's not, in the grand scheme of things, it's not too important to be able to derive that. But you do need to have your, let me find it. You do need to have this right here. This absolutely must be memorized. Okay? So I'll see you guys.